Imagine this: you step inside a sleek spacecraft, the engines hum softly, and within seconds, stars stretch into glowing lines. Planets blur, galaxies shrink behind you. And you've just broken the ultimate rule of the universe. You're traveling faster than light. It's the dream that has fueled science fiction for decades. Warp drives, wormholes, hyperspace, all built on one question: what if we could go beyond light speed? Because if we could, the entire universe would become our playground. Distant galaxies wouldn't be unreachable anymore. Time itself could bend and twist. But as exciting as it sounds, faster than light, FTL travel challenges the very foundation of physics. Einstein's theory of relativity says nothing, not even information, can move faster than light. Yet some scientists are daring to ask, what if there's a loophole? What if the laws of nature allow it, just not in the way we expect? Let's explore what would really happen if humanity found a way to break this ultimate barrier, and what strange, terrifying, and mind-blowing consequences it might unleash. To understand why light speed is so special, we have to go back to Einstein's discovery. According to relativity, the faster something moves, the more its mass increases, and the more energy it needs to keep accelerating. As an object approaches the speed of light, its energy demand becomes infinite. In other words, you'd need infinite fuel just to reach light speed. That's why, according to physics as we know it, faster than light travel is impossible. But humans have never accepted impossible easily. Scientists began exploring theories that could bypass the problem, not by moving through space faster than light, but by bending space itself. That's where the concept of a warp drive comes in. Think of space not as empty, but as a flexible fabric that can stretch and contract. If you could compress space in front of you and expand it behind, you wouldn't be moving faster than light. Space itself would be moving you. To the universe, you'd still be standing still, but to an outside observer, you'd appear to travel light years and seconds. It's not fantasy, at least not entirely. In 1994, Mexican physicist Miguel Alcubierre proposed something revolutionary: a mathematical model for a warp bubble. Inside this bubble, space-time would contract ahead and expand behind, allowing a spacecraft to surf the distortion. The ship itself wouldn't move faster than light within its bubble, but the bubble could move faster than light relative to the rest of the universe. It sounded like something straight out of Star Trek, but it was published in a real scientific paper. The problem: energy. The Alcubierre drive would require more energy than exists in the entire observable universe. Worse, it demanded something that may not even exist: negative energy or exotic matter. This strange form of matter would have to bend space in the opposite direction of gravity, essentially repelling it. No one has ever seen such material, though quantum physics suggests it might exist briefly at subatomic scales. Still, even that tiny glimmer of possibility keeps scientists dreaming. Because if we could harness it, we could, theoretically, fold space like paper and step across galaxies. But before you pack your bags for Alpha Centauri, there's a catch, or rather, several. For one, faster than light travel may break causality, the logical order of cause and effect. If you move faster than light, some theories suggest you could arrive at a destination before you even left. That means you could, in theory, send messages, or even yourself, into the past. It's the classic grandfather paradox. If you went back and changed the past, would the future still happen? Some physicists argue that nature simply wouldn't allow it. The universe would prevent paradoxes by making such actions impossible. Others think time might branch into alternate realities, each one forming a new timeline where different outcomes exist. So, faster than light travel might not only let us cross galaxies, it could let us cross timelines. But that opens a new nightmare. If every jump creates a new version of reality, what happens to the one we leave behind? Would our home universe continue without us? Would there be infinite versions of us scattered across infinite realities? The physics may be uncertain, but one thing is clear: time and distance would never be the same again. Let's imagine for a moment that FTL travel is possible. What would it actually feel like? You board a ship designed to warp space, powered by reactors generating unimaginable energy. The engines ignite, not with fire, but with silence. Space bends, light twists, and in an instant, the stars outside stretch into surreal ribbons of color. Inside the bubble, time feels normal. Outside, however, time warps dramatically. To someone watching from Earth, your journey might appear to take decades, while for you, it's over in minutes. You could travel 20 light years and return to find that centuries have passed. This phenomenon, called time dilation, already happens at near light speeds. Astronauts aboard the International Space Station experience it, though on a much smaller scale, aging milliseconds slower than people on Earth. At faster than light speeds, the effect becomes mind-bending. For travelers, space shrinks. For observers, time stretches infinitely. So if humans ever do go faster than light, we might not just become explorers of space, but of time itself. But what kind of engines could make this possible? Current rockets, even the most advanced ones, are laughably slow for interstellar travel. Our fastest spacecraft, NASA's Parker Solar Probe, travels at about 700,000 kilometers per hour. Sounds impressive, but that's only 0.06% the speed of light. At that rate, reaching our nearest star system, Alpha Centauri, would take over 6,000 years. To reach light speed, we'd need entirely new physics. Scientists are exploring exotic propulsion ideas, like antimatter engines, photon drives, and fusion propulsion. Antimatter offers the highest known energy output, converting mass directly into energy according to Einstein's equation, E = mc dal. Just 1 gram of antimatter could power a city for days. But producing and storing it safely? That's another story. We've created antimatter in labs, but only in microscopic amounts, and it annihilates instantly upon contact with matter. The technology to harness it on a spacecraft doesn't yet exist. That's why some researchers are shifting focus from moving faster to bending space. A warp drive might not break physics. It might simply use physics in a way we don't yet understand. At this point, you might wonder, even if it's possible, should we do it? The universe isn't built for comfort. Space between stars is filled with radiation, debris, and gravitational forces beyond comprehension. A warp bubble or wormhole might expose travelers to intense cosmic hazards. A tiny miscalculation could send a ship light years off course, or into a black hole. Then there's the human factor. FTL travel means isolation on a cosmic scale. Communication with Earth would be nearly impossible across time and distance. You might return home to find your civilization long gone, your loved ones dust in history. But that's also the beauty of it. FTL travel would force us to see humanity not as Earth-bound, but as cosmic. It would demand unity, courage, and vision. The same traits that pushed ancient sailors across oceans and astronauts to the moon. Each journey would redefine what it means to be human. Let's take a step back. Even if we can't yet travel faster than light, we're already moving toward that dream. Scientists are experimenting with light speed simulators, spacecraft concepts that approach relativistic speeds without breaking the limit. These could reach nearby stars within decades, not centuries. Projects like Breakthrough Starshot aim to send tiny probes to Alpha Centauri using powerful lasers from Earth. These probes could reach 20% of light speed, fast enough to reach another star in just over 20 years. It's not warp speed, but it's the first real step toward interstellar travel. And who knows, just a century ago, the idea of walking on the moon seemed impossible. Yet within a few decades, we made it real. If history has taught us anything, it's that what seems impossible today might be reality tomorrow, once we understand the universe a little better. Now, let's imagine the world after we achieve it. Faster than light travel would transform civilization completely. Colonies could spread across galaxies, connected by fleets moving between stars. Time itself might lose meaning. A journey that feels like an hour for one traveler could equal centuries on another planet. Entire generations could be born, live, and die while a single ship moves through warped space. Politics, culture, and identity would evolve beyond Earth. Human might come to mean something far more cosmic. We'd meet new worlds, maybe even new forms of life. And every trip would raise profound questions. Are we expanding humanity or escaping it? What does it mean to explore? When exploration might rewrite reality itself, FTL travel wouldn't just open new frontiers. It would force us to face who we truly are, creators, explorers, or conquerors. Yet, amid all the wonder, there's a deeper mystery. If faster than light travel is possible, where is everyone? This is part of the famous Fermi paradox. The universe is ancient and vast, billions of galaxies, trillions of stars, countless planets. If even one civilization had developed FTL technology, we should have seen signs by now. So where are they? Perhaps FTL travel destroys those who attempt it. Maybe civilizations vanish when they tamper with the fabric of time. Or maybe, just maybe, they're already here, observing silently, moving between realities faster than we can comprehend. It's a haunting thought. Maybe the speed of light isn't just a limit. Maybe it's a barrier meant to protect us from what lies beyond. If this journey through the science of impossible travel fascinated you, make sure to like, share, and subscribe for more deep explorations into the mysteries that define our universe and our future among the stars.